New trivalent europium complexes with pharmaceutical ligands, synthesis, characterization, and spectral study. Authors: Jorge Fernando Silva de Menezes, Andrei Marcelino Sapires Silva, and Karine Tondo Alves. In this work, we synthesized new trivalent europium complexes using the ligand beta-decatenate benzoyl trifluoroacetone, also known as HBTFA. As secondary ligands, we used water, amoxicillin, nitazoxanide, and quinoline. This research was based on the principle of the antenna effect, in which the ligand absorbs energy and efficiently transfers it to the emitting ion. The synthesis was carried out by dissolving trivalent europium chloride hexahydrate in ethanol. Then, this solution was reacted with the ligands, forming the desired complexes. Samples were prepared with each secondary ligand for subsequent spectral characterization. The infrared spectra confirmed the coordination of the ligands to trivalent europium. There was a shift in the stretching vibration of the carbon equals oxygen bond, originally at 1,770 reciprocal centimeters, due to electron delocalization. The emission spectra of all complexes displayed the characteristic red color of trivalent europium. Excitation was performed with ultraviolet light, around 400 nanometers. The excitation spectra showed peaks between 366 and 372 nanometers. These peaks correspond to efficient sensitization channels for emission at 612 nanometers. The transition, 5D0 to 7F0, was observed as a single line at 579 nanometers, indicating high purity and symmetry around the ion. The transition 5D0 to 7F2, associated with the red color, was the most intense in all complexes. This demonstrates the predominance of short-range interactions. Changes in emission profiles were observed when comparing complexes with different secondary ligands. These changes reflect differences in local symmetry and in the chemical environment around the metal. The lifetimes of the excited states ranged from 30 hundredths to 46 hundredths of a millisecond. The decay followed a mono-exponential behavior, indicating a single symmetry site in each complex. The analysis of Judd-Ofeldt intensity parameters showed that the omega-2 parameter was greater than omega-4 in all complexes. This indicates greater polarizability and covalent character in the bonds between trivalent europium and the ligands. Coordination with amoxicillin and quinoline resulted in an increase in quantum efficiency. Coordination with nitazoxanide, however, reduced this efficiency due to electron withdrawal effects. Synthesis with beta-diketenates and pharmaceutical ligands yielded complexes with higher luminescence than the hydrated precursor. The spectral properties suggest potential for applications in optoelectronic devices and in the development of biomarkers.